All right, so in your notes, please label them. Label the notes as sine and cosine curves. Sine and cosine curves. So the first thing that I want you to write down is to calculate the x and y on a 1 unit circle. What do you do to find the x and to find the y? What do you do to find the x value if you are on the 1 unit circle and you need to find the x value? You take the cosine of whatever the angle is. So we say it is the cosine of theta. What technically is in front of the cosine of theta?
1.
There's a 1 in front of it. Why is there a 1 in front of it? It is a 1 unit circle. Yeah. We haven't even really talked about the 1. We've just said take the cosine of the angle, take the sine of the angle. But technically, you're really taking 1 times the cosine of the angle, and we're doing a 1 because it is a 1 unit circle. In other words, the radius of the circle we've been working with is just 1 unit. What about the y value? How do we find the y? It's 1 times the sine of theta. And that shouldn't be new information. You guys should already know what we've done that a couple times now already. So, all right, but what happens? What if the radius is 5 instead of 1? What do you do to find the x? I was wondering whose that was. Okay, good. What do you do if the radius is 5 instead of 1? What do you do to find the x value? Yeah, you're going to take 5 and you are going to multiply it by the cosine of theta. And if you want the y value, you take 5 times the sine of theta. So the generic old rule for calculating the x value and the y value, the algebraic rule, I guess, is that if you want the x value, you always take r, what does that mean? The radius, times the cosine of theta, and then to find the y value, you take r times the sine of theta. And I'm going to make a little note up here that r is the radius of the circle. Sometimes I will try to trick you and I will say the diameter of the circle is 20. Do you want the diameter? 10. No, you don't want the diameter, you want the radius, which is 10. You'll use pencils. So make sure you're watching carefully, looking for the appropriate words and so on. Alright, so this is your rule. X is r cosine of theta, y is r times the sine of theta. All right, what I would like to do now is I want to graph in your notes a cosine curve and I want to graph a sine curve. Yesterday we graphed one of each. It was the first time you had ever done it, but now we need to get it in your notes. So please label this part y equals the cosine of theta. By the way, what is the radius in this y equals equation? What is the radius?
1.
Radius is 1, okay? Do your best. Do your best here. But what I would like you to do is draw an x and a y axis. Draw an x and a y axis as neatly as you can. And what did we do yesterday? What went right smack in the middle? 0 degrees. Yeah, but that was the point. That was like 0, 0. The 0 degrees. What happens at 0 degrees? What is the cosine value? You might want to get out your blue unit circles. What is the cosine value at 0 degrees? Go to your blue circles. look at 0 degrees. What is the cosine? Cosine is x. What is it? It's 1. The cosine value is 1. So at 0 degrees, you have 1. So you go to 0 degrees and you put a point there. Then we took 1 step to the right. What was 1 step to the right? Do you recall? How did we label the x-axis yesterday? 90 degrees. So 1 step to the right was 90 degrees. Another step to the right was 180. Another step, 270. And then we have 360 degrees. So when I take 1 step to the right to 90 degrees, what is the, go to 90 degrees now, what was the cosine value at 90 degrees? Should be 0. What is the cosine value at 180 degrees? Should be -1. So now I'm going to go down to -1 and put a point. What about the cosine value of 270 degrees? 0. And what about the cosine of 360 degrees? Should be 1. So at 360, I'm way up here at 1. Connect your points. Remember, we are not drawing zigzags. We are drawing nice, pretty curves. But if you remember, the cosine curve can be mirrored on the other side of the y-axis. So I can work backwards now, too. So I'm going to take 1 step to the left and make it -90 degrees. I'm going to fill in my degrees right now. -90, -180, -270, and -360. All right, so what is -90? Where is that on the circle? That would be if you had rotated in a clockwise direction, putting you down at 270. So go to 270 degrees on your circle. What is the cosine value?
0, -1.
Cosine value, so you just want the 0. You want the x value at -90 degrees. You get 0. What about -180 degrees? What is the x value at -180? Should be -1. The x value at -270 is 0, and then the x value at -360 is a +1. So connect your points, and this is your cosine curve. What I would like you guys to do now is recognize that this curve, the cosine curve, and the sine curve too, and we'll talk about that one in just a minute, but the cosine curve has 5 main points. And if you can remember your 5 main points of a cosine curve, graphing these things is a piece of cake. This point right here, so always start at the y-axis when you're looking for your 5 main points. This point right here is what we call a maximum. So label that point on your curve as a maximum value. This point right here is an x-intercept. What do you think we're going to call this point down here underneath the 180? It's going to be a minimum. And then as I continue along my curve, when I get to 270, I'm at a what? We're at another x-intercept. And then my last point over here is another what? Is another maximum value. So we go from a max to an x-intercept to a minimum to an x-intercept to a maximum. Get out your notes, please. Get them out. Max, x, min, x, max. You need to remember those points, and I'm going to have you guys, can I flip pages? Can I go on to the next one? I want you to write this down. The 5 key points. The 5 key points. What was the first key point on the cosine curve? What was the first one we labeled? Maximum. Yep. On this graph right here, we started by labeling a maximum. So when you're graphing these things, you want to graph a maximum first. And then the next point after that was an x-intercept. And then it went to a minimum. And then it went to an x-intercept. And then it went to a maximum. Let's make a note too that this is the cosine. This is for cosine because something different happens when you are graphing a sine curve. Yeah.
So this is only for cosine.
Only for cosine. The order changes a little bit when you are talking about the sine curve. All right. So before we go on, what I would like to do now is graph another cosine curve. So draw yourself another x and another y-axis. We're going to put 0 degrees in the middle. Label them 90, 180, 270, and 360. Negative 90, negative 180, negative 270, and 360. And let's graph y equals, let's do 4 the cosine of x, or 4 cosine of theta. X and theta mean the same thing, so sometimes I might use theta, sometimes I might use x. If you're going to graph this, how high is this graph going to go?
4.
Why is it going to go 4 high? Yeah, there's a 4 in front of it. That's the radius of the graph, and it will always go as high as its radius. Now, if it's going to go 4 high, how low is it going to go? It's going to go negative 4 low. Very good. So go up here, and I don't care where you on your y-axis label the 4. If you have labeled it 4, it's going to go 4 high. I'm going to go equally far low, and I'm going to label it a negative 4. Now, you should have just written down these 5 key points. When you are graphing a cosine curve, the first thing you want to do is graph your maximum value. So you don't always have to go back to your circle and figure out what's the cosine at 0 degrees, what's the cosine at 90 degrees, and so on. Just remember that when you graph a cosine curve, you always graph your maximum value first. So go to your y-axis. Where's your maximum value going to be? It's going to be at 4. The next point that you're going to graph is an x-intercept. So you go over here to 90 degrees and you put a point at right along the x-axis. You go to 180 degrees. The next value that you need to graph is a minimum. So you graph your minimum point. Then you graph your x-intercept. And then you go back and graph another maximum. And if you can remember those points, you're good to go. With a nice pretty curve. But now you need to go backwards. The cosine curve, remember, is like a reflection over the y-axis, so you can just swing it over and map it right onto the other side of the y-axis. Or you can look at these points, these 5 key points backwards. Start at the end with your maximum, which we've already graphed here. Take 1 step to the left. You're at an x-intercept, so I'm down here. Take another step to the left. You're at a minimum, which is negative 4. Take another step. You're back at an x-intercept. 1 step to the left. You're back up at your max. Connect your points. And here's your cosine curve.
How are you today? That's good.
Questions? Anything I can address or clear up or anything right now? You feel okay about this? Yeah, okay, good. Guess what we're going to graph now? We're going to do the sine of theta, or the sine of x. What's the radius in this problem? 1. Draw yourself an x and a y-axis. Here's your y-axis. Here's your x-axis. Let's go ahead and do all of our labeling right now. 0, 90 degrees, 180, and so on. Make sure you have your blue circles handy. sine values mean y. They mean the y. So look at your blue circles. What is the sine value at 0 degrees?
0.
It is 0. Yes. So you put a point here. At 0 degrees, the y value, the sine value is 0. At 90 degrees, what is the y? What is your sine at 90 degrees? Should be 1. If you look up at 90 degrees at the top, the y value is 1. So you take one step to the right, you're up here at 1. At 180 degrees, it's 0. If you go to 270, it is -1. If you go to 360 degrees, you're back at 0 degrees. Connect them. And now you have to work backwards.
Yay.
So at -90 degrees, I think you, now remember this one is not just, it's not just a flip over the y-axis. If it's up here, if we're up here at our high point, we have to go all the way down to a low point over here before it's going to go back up. So at -90, the sine is -1. At -180, it's 0. At -270, it's 1. And at -360, you're back at 0. Connect your points. And that is your sine curve. It should look very, very similar to the cosine curve because it is very similar to the cosine curve. It's just shifted over a little bit. And now what we need to do is, I want to get your key points down. So let's say 5 key points. And this is for a sine graph. Uh-oh. This is for a sine graph. The 5 key points. Look at your y-axis. Look at your y-axis. What is the first point along the y-axis? 0. So what do we call that? We don't call it 0, we call it a what? X-intercept? So our first key point is an x-intercept. What's our next key point? This right here, this is an x-intercept. This point right here is a maximum. So our next key point is a max. This point right here is another x-intercept. So that comes next. This point down here is a minimum. And then this point up here is an x-intercept. So these are your main points for graphing a sine curve. If you can remember those, knowing that pattern, it makes graphing these things a lot easier. So now what I want you to do is take this information and let's graph y equals, what do you want to do? 12. Let's do 12, the sine. This time I'm not going to call it theta, I'm going to call it x. Means exactly the same thing. Drawing your y-axis, drawing your x-axis. Do your labels. Got 0 in the middle. And then 90, 180, 270, 360. And go backwards 2. Now, like I said before, you don't have to keep going back to your unit circle and figuring out what's the sine value at 0, what's the sine value at 90, and so on. Instead of doing that, just rely on those key points. What is your first key point for a sine curve? The next intercept. So right here at 0 degrees, put a point there. What is your next key point? The maximum. Where is the maximum?
12.
How do you know it's 12?
Because it's in front.
Yep, because it's in front. What do we call that number? Radius, yes. This right here is our radius. That tells us how high it's going to go and how low it's going to go. I don't care where you go, but you got to label it 12. If you say it's 12, it's 12. So I go 1 to the right, I go up here to 12. 1 to the right, I'm back at an x-intercept. Take another step to the right, I'm down at -12. Take another step to the right, you're at 0. Connect your points. So it went x-intercept max, x-intercept min, x-intercept. -90 is -12 at -180. In other words, I'm looking at my key points backwards now. So if I look at these key points, if I go x-intercept, min, x-intercept, max, x-intercept backwards, then I can follow that pattern to graph the left side of this sine curve. You guys feel okay about that? So if I ask you to do that today, the first thing, which I'm going to give you guys an assignment here in a little bit, and the first thing I need you to make sure that you're looking for is a radius, because I'll give you a circle and I'll say where, put your x and your y at a certain degree. Lots of people in second hour forgot to look for the radius. You gotta look for the radius. I'm giving you extra stuff to do to remember now. You gotta be looking for the radius. All right, what I want you to do now is keep going on your notes. I want you to draw yourself a circle and try not to be terribly stingy with it. Draw yourself a circle, and this circle is going to be a clock. I'm really always astonished at how many students don't know how to read an analog clock. Too much digital stuff, too many cell phones. What goes at the very top of an analog clock? 12 o'clock, all right. What goes at the very bottom? 6. And then we've got 3 over here on the right, and we have 9 over here on the left. So what I want you to do now is maybe just draw a dash segment right through the noon and the 6, or midnight and 6, and then do the same thing for a horizontal line from 3 to 9 too. What did you just draw?
A clock.
A clock, yes. What are those things that I just drew in? What quadrants? Yeah, I drew in the x and the y axis. So what I just did was I took that clock and I divided it into 4 parts. Yeah. How many degrees is 3 o'clock? We call that 0 degrees. So on the outside of the circle, let's label that 0 degrees. What about up here at noon or midnight? What is that?
90.
90. What about over here at 9?
80.
And then what about at the bottom?
270.
That's 270 degrees. All right, so let's go in and fill in our 4 and our 5 and 7 and 8 and so on. Fill in all your missing numbers. This should look oddly familiar to you. This is a unit circle, just in terms of a clock, and an analog clock instead of just a circle. So what do we call 2 o'clock? 2 o'clock is how many degrees?
30.
Should be 30 degrees. This right here is 30. What about 1 o'clock? It's actually not 45. 45 would show up halfway between 1 and 2. So 45 really doesn't do us a ton of good on this clock. Yeah, it would be 60 degrees. Yep. So in other words, I'm taking this 90-degree quadrant right here and I'm dividing it into 3 parts: a 30, a 60, and then there's a 90 degree. Yeah.
So all around it's actually just adding 30.
Yeah, adding 30 to each degree. And we're ignoring the ones where we added 15s. In other words, we don't have a 45 on here. We don't have a 135 and so on. All right, I'll pick your head up. 150, 180. What is 8 o'clock?
210.
210. Kyle? Good morning. 7 o'clock is 240 degrees. 6 o'clock is 270. What's 5 o'clock?
300.
300. What's 4 o'clock?
330.
330. And then, of course, 0, 3 o'clock is otherwise known as 360. Okay. What I want you to do now is draw in a minute hand. A minute hand, of the 2 hands on a clock, the minute hand is the longer one, and then the hour hand is the shorter one. Draw in a minute hand at 7 o'clock. Draw it right to 7 o'clock. right here at the middle of the clock, we would call that the origin, 0, 0. So if we have a minute hand that is pointing at the 7 o'clock, and I asked you to tell me what is the X position and the Y position relative to the center of the circle, what are you going to do to figure out, by the way, I forgot to give you crucial information. What did I forget to give you? I didn't give you the radius. I didn't tell you how long the minute hand was. The minute hand, how long the minute hand is approximately the radius of the circle. So what do you want it to be? 3 inches. We have a 3-inch radius, a 3-inch minute hand. What is your X and what is your Y if the minute hand is at 7 o'clock? You're pointing at 7 o'clock. So we have I'm going to write this down over here on the side. We have a radius of 4. No, what did we say it was?
3.
We said 3, didn't we? Maybe last hour it was 4. I can't remember. We have a radius of 3, and we are pointing at 7 o'clock. We're pointing at what degree?
40.
We're at 240 degrees. So what is the X value right here at this point? What do you do to figure it out? You're going to do the cos of 240, but what else? You got to multiply it by 3. Multiply by the radius. So to find the X, you're going to take 3 times the cosine of 240 degrees. And then to figure out the Y value, you're going to take 3 times the sine of 240 degrees. What kind of number should you get? Both of these numbers should be what? Negative. They're in quadrant 3. Both the X and the Y in quadrant 3 are negative. So do 3 cos 240. Can someone get me a value? Make sure you're in degree mode. Negative 1.5. Thank you. And then what is the Y value? Negative 2 point what?
6.